Well, the other day, driving my car, I hit a crack and something fell for the headliner. I'm thinking like, alright, we got a problem. Lately, my G6 has developed a little bit of personality quirk, especially a critical tiny piece of plastic decided was done with his job. So, let's fix it. First of all, this is not a step-by-step tutorial. I'm not here to tell you what exact dimensions or which material you should buy. What I want to show you is how to approach a problem like this, because once you understand the process, you can apply to almost anything. This part failed, and the first thing I tried to understand isn't not how it broke, it's what it broke. It was stressed, it was vibrating, or it was exposed to the sun for many years. If you skip this step, you'll just remake the same problem. You can always recreate something exactly as it was, but doesn't mean you should. This is the point where I decide what actually needs improvement. When I sketch a part like this, I'm not thinking about how clean it looks. I'm thinking about function. Where does the force enter? Where does it exit? Where should the part stay rigid? And where can it relax? If you can answer those questions on paper, CAD won't magically fix it. This is not just about recreating, it's about improving. Where can I add material? Where I can reinforce it without damage the impact. The goal is not just make a replacement, but a better replacement, something that will actually outlast the original. CAD is where bad ideas stop being allowed. Every dimension is a commitment. A good rule I follow is if you can explain what a feature exists, it probably should not. Now, instead of just extruding the base shape, I'm thinking about internal stress. The original was thin here, so I'm increasing the wall thickness about 40% and adding a small rib structure for added rigidity, designing for manufacturing. One mistake people make with 3D printing is designing parts as if printing doesn't matter, but how something is made is part of the design. Layer direction, weak points, how forces travel through the print. Ignoring this is how part fails early. Once the printer starts, you're no longer designing, you are testing your decisions. Before installing anything, I always do a reality check. Does it feel solid? Does it fit naturally? Does it look like it belongs in this car? If something feels wrong here, it usually is. This is where theory meets reality. Cars are not perfect environments. Nothing lines up perfectly, nothing loads perfectly, and nothing behaves exactly like it does on the screen. So this step is about observation, not forcing things. When it works, it doesn't feel impressive. It feels correct, like it always meant to be there. If you're trying to do something like this yourself, don't focus on copying parts. Focus on understanding them. Ask why they exist. Ask why they fail. Design with that in mind. Do that, and the tools become secondary. And that's how you fix things properly.